Hey guys, how's it going? Welcome to another episode of Ferris Makes Hardware. Continuing from last week, I want to continue working on kaze, which is the HDL that I started back in like August, and started moving everything to Rust in the last couple weeks, and still working on that. It's going well. I'm trying to really do it properly and document things and make it a thing that I can actually publish properly on Crates.io, and hopefully that's something other people can try, even though I'm not really aiming for a very high abstraction level, because I think it's really important to get like a solid foundation first and then explore those patterns in projects, and then maybe they make it back to the actual thing. The main thing we're solving is trying to get an HDL that is nice to write and also integrates really well with a Rust-based testing setup, which I would really like to have. Anyway, hi to guys in the chat. G Superland, glad you can make it. Same to you, Chief Detector. Dark Second, Garrett Kelly, Daniel Collin, Mad Moose. Good to see you guys. Let's see. I didn't really think much about what I wanted to work on next. I guess I could mention what I did more recently. So last week, I think. I keep forgetting that running these tests uses a lot of CPU. Hopefully you guys didn't see any interruptions there. But I think last week I spent a bunch of time implementing some binary operators. So in particular, I have this ticket that mostly is about getting to feature parity between this new implementation, the Rust one, and the Python implementation that I had before in the XenoWing repo. All this is public, of course. But it's unlicensed so far, and that's mostly just laziness. I'm just going to do the standard dual MIT and Apache license for this project as well, at least. And then I was thinking actually about licenses for the XenoWing code. And actually, since a lot of that's going to end up being Rust anyway, I might as well license that the same way. So I'll probably try to do that. And then there's still going to be some Verilog, which I guess I'll try to license the same way. Anyway, part of that was implementing a lot of these binary operators, so got through a few of those. I think some of the simpler ones, bit XOR. I don't remember if I did these comparison ones on stream or not. I haven't done any of the sign stuff. In fact, I might even hold off on these. Yeah, it does actually need one trinary operator, which is the mux stuff, and that's actually implemented but not documented. And I might change the order of the arguments to look more like a ternary expression. We'll see. Because actually, another thing that happened is I was looking at spinal HDL, which is one that I had heard about but never really looked into. And actually, the internal model here seems to be really similar to what I'm doing. It's a bit different, and there's a lot of things I don't like about spinal. So I'm kind of happy to have my own, but overall, in terms of like which HDL this Rust one that I'm working on is closest to, it would definitely be that one. So it was cool to have a lot of those ideas kind of validated. And even some of the implementation is similar. Like there's a whole page in their documentation about how nodes that are not accessible eventually through the outputs of the top level module will be pruned. And that same thing happens with kaze at the moment, and I'm going to keep doing that. And that's just a consequence of how we search the node graph, because essentially both these HDLs are based around building a netlist more directly than describing that netlist behavior, which is kind of what Verilog does. And then it has to infer the actual netlist. So let's see a good example of that. Like in this operator test, if you want registers, you ask for a register, and then you get the register, and you can drive its next value with, for example, an input, and then drive an output with the register's value. So like this is it's very clear that we're building a graph here, and it's kind of explicit about that. And then we traverse that graph to actually generate the output. Currently, of course, one of the things that's missing for feature parity between this and the Python implementation that I had is that this actually doesn't generate any Verilog right now, and that's purely because I've been focusing on the simulator generation, which this will generate, of course, Rust code. So for example, that module that I mentioned, or that I just showed here, if we look into this modules file here, there's a reg test. Yeah, it's here. So it generates this code based on that HDL description. So we have the module itself as a struct, and then it's got these inputs and outputs, and also has a couple internal, some internal state for this one register that we asked for. And then it has this reset method, which is going to reset that to its initial value, which I don't think we specified one in that particular code. Yeah, we said none there. But it's going to have this as a default value. In fact, I might actually make some stuff to random initialize this and not necessarily have a default value for every register, which that's something that I wanted originally, but I'm thinking that you can actually save a lot of logic, especially in really wide data paths, by not having default values for these registers, which means that you need to often have several reset clocks on the actual device, but that's something that we could support relatively easily. And then it has this method to simulate the positive edge of a clock, in which case it just transitions the register into its next value, and then you can propagate the signals through it as well, which is, in this case, just outputting the register value and then also propagating the input to the next register value. So really straightforward. And one of the things that I did this week that was really good is I started implementing instantiation. So the idea there, this is the nice thing about having tests, is that I have examples. So these are maybe a little bit verbose actually for some of these. And I don't think I did document how to make instantiations. Anyway, the point is that you need to, once you have a module description, so for example, here's this inner description, which I guess is called M in this case. And the inner one just has a couple inputs and a register, and then it drives that register with the inputs ANDed together and then outputs that. So really basic module for this inner one, and then it creates an outer one where it has a bunch of these inputs, and I think it creates a few instances of this inner one in this case. So in this case, we have this input 1, input 2 for the module, and those go into the input 1, input 2 of this module instance, and then we do that a couple times, and I think we do this little tree where it's essentially this AND gate and a register, and then this AND gate and a register in parallel, and then the outputs of those are put into this AND gate and a register, and then we get the output out of that. So this syntax is a little bit verbose. It's not nearly as verbose as the equivalent Verilog, so I shouldn't really complain about that, but it's still a bit more than I would like, especially if you want to drive several inputs at once. So I might also just add some syntactic sugar on top of that, but that's the kind of thing you can do again in user code. So I want to play with some patterns for that before I commit to that in this library. But anyway, that this actually is handled correctly. This also gets generated. It's here actually is the output, and it's this last one here. So the way I actually do it for simulation is I just flatten the whole module hierarchy, because this HDL doesn't allow combinational loops, which means you can always propagate all the signals in one pass and in one direction. So you never have to reevaluate parts of the graph. It's all just straight line code, which makes it really easy to generate it. But then the generator needs to take this module structure and flatten it, and it also needs to detect loops, which is one of the things that I haven't done. So I've marked on this ticket, I haven't marked mark instantiation as finished, because it does appear to work, but I need to add a lot more tests for it. And I think there's a bunch of tests that I have added too. Let's see, in module. Yeah, so I did actually document the function to create an instance. In fact, I'm going to, again, pull up the proper docs for this because it's easy to show you there. Doc, no deps, open. So module here has an instance function here. So you give it a name of an instance, and then it creates an instance of whatever that module is within sort of your current module. So again, it's a simple example here where you have this inner module. In fact, in this case, it just propagates the an input to an output. And then we create an outer module, which then we make a instance of inner inside that. And then I think this just pipes a new input into that module's input and then drives a new output by that module's output. So this is really, really basic. But yeah, this works. But it says here, like, panics a module name doesn't exist in this context, or if creating this instance would cause this module definition to become recursive. And actually, this second half is not true right now. The implementation does not do this. I think we can detect those combinational loops here, but it might actually have to be deferred until we compile for the simulator or the output Verilog. And that might be for performance that I want to do that, because otherwise you're checking for loops by essentially doing a potentially complicated search every time you hook up an input or output, because you basically have to, like when you hook up, basically make any of these connections, you need to look at whatever the input to the connection is. So in this case, you drive this input with this signal, so then you have to look to make sure this signal, you basically have to do a search through all of the nodes that can feed into this, and make sure that this one never comes up. So I think it makes sense to do this while we're already traversing the graph like that to generate the simulator code or the Verilog code. Yeah, so about macros, there's I do think this is one place where that could be applied nicely. And in fact, you could probably have a syntax where you say like connect, or whatever, the instance.connect, and then some like arrow syntax or something to make this nice. I'm not really sure how I want that to look. But again, that's the kind of thing that could live nicely in user code until I find a nice pattern. I think the first release of this library will just have it be pretty basic like this, and then people can build whatever abstractions they want. But the other thing that I definitely want is have a nice syntax for conditionals. So I played with this a little bit in some of the code down here, actually. Again, this is in this build test. This is the implementation of the macro. But it would look like this. So the idea is that you want to be able to have an if conditional like syntax that would make these signals conditional on these other signals. So this is not an if at this sort of compile time. This would be an if in the actual logic. So you kind of opt into this syntactic sugar, and then every assignment and if statement within that block actually has a special meaning. So I actually made this work in the Python implementation, but it relies on some C Python. It basically relies on being run in C Python, which is okay if it's just a generator that I use myself. So it's not that nasty, but it is still pretty nasty. But the way I did that, let's see if I find an example. Let's see. For example, display.py I think has this. So I would say like load start is this, but then if this is the syntax I had in Python. So with this if construct, and then this is the condition, then all the assignments in here actually get rewritten. So essentially what you want to do is let me find a good way to explain this. So let's say I wrote some signal. So some signal S is some input. But then I also have, like, let's say I have a reg is m.reg, and this, let's say this was 32 bits. Actually, we'll make it 1 bit to match with this input, right? And so then let's say I had another condition. So let's say I wanted to describe this. If m.input select, then I actually want S to be reg's value instead of what S would be. And then here I can do something like reg.drive next with S. Yeah, that would work for a second. So this is kind of the code that I want to write. And then what this thing translates into is something like this. You basically reassign S, where you say S is m.mux, and then you would either have like the selector, so input cell, and then if this is low, you want this to be the previous value, so then you have S, and if it's high, then you want it to be this value. So you essentially want to write all of all of the conditionals like this. And this doesn't seem like it's that nice for this one case. I mean, it does look a bit better, but there also might be cases where you want to write this directly, so you don't always want to use this. But with one signal, it doesn't really make that much of a difference. But where it really makes a difference is if you start nesting these, or if you have two signals. So if you have some other signal, which let's say t is some other thing, then this also, you'd want it to rewrite t to be also conditional on this input. So, and in particular, this also I think would kind of look like, actually this might be an issue, the way this is written like this with these side effects. Might have to think about that, but I think you want to rewrite it essentially like this, where you have let conditional is this, and then it works out, I think. Yeah, like this. So you basically want to rewrite the code like this. And again, with like nesting, so let's say you want this, and then you want maybe some other conditional, and then have some more code, and then you might even have some else stuff here. So yeah, the point is you want to have at least this kind of nice syntax. And I think even just starting with this, where I only support conditionals and assignments, would be really natural. However, when I actually tried to do this, which is kind of the point here, I had a lot of issues actually implementing this nicely with regular macros. So I want to explore using procedural macros to do this, which I think should be the right tool for this job. It seems like that's a lot more straightforward than this kind of crazy stuff that I tried to do here, which ultimately doesn't actually work that well. You can see a bunch of these to-dos for like problematic case. I don't think all of these are actually problematic in this particular attempt, but I know some of these were. So that's one case where like I really want some syntactic sugar to help out with describing the logic. Hey, Mr. Liquid. In terms of sugar for other things, I'm always really hesitant to like add that stuff too early. But again, all this can live in user code, which it kind of doesn't in this case, because it's kind of messy to have this in the test file, but it's just something I was trying, so that's where it is. So yeah, that's something that's also on this list here. And also to like document a bunch of stuff, because again, I'm kind of putting in the effort to really try and make this nice. Things you can do on an instance and things like a signal. And I want to write like a little bit of an introduction to like the idea behind the language and what you're describing here. I call it a language just because a lot of these they call them embedded HDLs. They're really just APIs for describing netlists in some form or another. And a lot of them more closely match Verilog, and how they have like some assignments that are combinational and some assignments that are sequential. But in the case, in my case, I've decided that I think describing the netlist like as a netlist is the most intuitive thing. So that's what I'm going for. And we'll see if that's a good idea. I mean, I know that I enjoyed using this kind of language in Python already, and I think having this in Rust and being able to generate simulators with it that integrate well with the test projects that I already have in Rust is going to be really useful. So it's going to be great. So I did see that. Excuse me, I did see that, and I forgot to reply. I got a good giggle out of that at work, and forgot to reply. But yeah, that's pretty funny. In very early 90s, in an awesome way. So I appreciate that. And then these sign operators, again, I might defer for now until I need them, because I can always add stuff to this API. And one of the things is that basically this language is all about sort of describing signals and then combining them. And these signals basically act like unsigned integers of a given bit width. And the bit width can basically be anything, except I do have a limitation that they can't be more than 128, because that simplifies the simulator generation, which is fine. So I totally forgot what I was gonna say mid sentence. That's cool. Oh yeah. So basically, you already have unsigned integers covered, and you can see that No, I haven't used enemy again. I've seen it, but I haven't used it. And at work, I actually don't do any RTL. I end up reading a bunch of it, but I don't write it at work. So, and we have a fairly large silicon team, so we don't. Maybe in parts that's used, but none of that kind of stuff is used as far as I know. Anyway, yeah, so you basically already have like unsigned integer stuff covered, except it doesn't play well with unsigned integer constants, or at least as well as I would like, because you have to kind of like build these value structures when you do most things, except actually with literals, I end up working my way around that. But I don't have any planned stuff for doing this stuff signed either. But the idea is I think that having basically everything be unsigned and then also sort of opting in for signedness on these operators is kind of the right approach at this level of abstraction. And then I think it's very possible to build another layer of abstraction right on top of this, where you actually would describe, hey, I want an unsigned integer. And then that would be implemented with these operators underneath. Or you could ask for a signed integer, and then that would be implemented with these and some of these underneath as well. So I think, hey, Okama. So I think this is kind of the right approach for this level, and then the rest of the stuff should be built on top. But I think honestly for the project that I'm working on, most of the time this will be sufficient. I actually don't think signed integers comes up very often in the project that I'm working on. So I'm basically just going to work at this level of abstraction until I see, and then just kind of build the different abstractions that I need. For example, being able to hook up multiple things to a bus and do memory mapping on that is something that should be really easy to describe semantically. As long as you know what the bus looks like and can compile down to this kind of netlist, which is also why it should make sense to describe a netlist as like a node graph, because it makes it easy to manipulate from higher level code, which is ultimately a really important thing. And that's also why I've chosen to do this as an embedded language rather than a language with its own grammar and everything, because metaprogramming is so valuable, and it's actually extremely important. But yeah. So yeah, what to do next? I don't know what I wanted to do next. Honestly, what I want to do is kind of get to a point where this small language is done, because I really want to get to working on the rasterizer again, which is kind of why I started all this, was to be able to do that and make it really easily integratable in the test project that I have. And so I'm getting closer, but still a ways away. So what would I enjoy doing most right now, I guess, is the question. Again, I think I'm going to defer these signed operators for now. I think that's fine. In fact, I'm actually going to mark that in this, that I can just defer these. Is that it, or is it just one? Yeah, I could work on Verilog generation. The other thing that I'm thinking about doing, which won't be in the first version of this, but is the ability to get signal traces. So essentially outputting, okay, this actually is out of date because all these were done. And so I'm going to do this. Yeah, that's fine. But yeah, I would like to be able to generate traces as well. And I need to come up with a nice way to do that. Not entirely sure what that's going to look like yet. But I think that's another thing I can defer. That's actually one of the, probably the thing that I that's like the worst about this approach. Like I think generating these simulators is fairly straightforward to do and also to test. So I trust that pretty well. But the fact that I have to explicitly implement traces that work nicely with like GTK wave, that's actually kind of annoying. I need to come up with a nice way to do that, but everything else seems to be going quite well with this. But yeah, I could work on Verilog generation. It should actually be really straightforward, because again, the whole Python version of this, that's all it did, and it was quite small. And the whole language is kind of designed to be able to generate Verilog easily. So the primitives have kind of been designed for that. Yeah, I'm actually thinking that as well, Dark Second, that I think I want to work on the if, because that's also something I've never done before, is procedural macros. So I think this is a good opportunity to learn that too. So I'm literally going to Google Rust procedural macro. And I think there's this post by Alex Crichton had a good place to start. So let's just dig into that, actually. The other thing with the Verilog gen is like initially I was just generating strings pretty much directly from the netlist graph, or what I call the module graph. That's what I'm calling in the API. So that's literally the module graph is. Can we go back to? Oh, I don't have the docs open anymore. Let's fix that. So the module graph is literally the modules and signals with them that you create with the API. So every time you do this, you make a module graph. You create a context, and then you make a graph of one or more modules. And then eventually you say, generate code for this one module. And in the simulator, it will flatten everything, and then that you just get kind of its own class or its own struct. In Verilog, it will generate a single module, and then like the instantiations just expect the other modules to also exist. And I think that's the right approach. So then there you would explicitly generate code for all the different modules, whereas the simulator only needs to generate one for the top level one, if you're going to simulate that. Or rather, it's going to simulate everything beneath what you ask it to generate a simulator for. So if you ask it to generate like a top level module, and then one of the modules inside of it, the code for the top level one isn't going to refer to the code for the lower level one. And in fact, they might even have different internals depending on what's reachable from the different outputs. So if there's some outputs from the inner one that's not reachable from the outer one, then the simulator for the outer one is not going to include any of the signals there. But I came up with a really nice like level of abstraction for generating the simulator stuff too. I generate these. I think I mentioned this last time, but I generate these. It's kind of a 2-pass thing. So initially, I take this module graph, and then I do 2 passes on it. One of them to see which registers are reachable. So I go back I take all the outputs, and then I make sure they're all connected, and I trace them all back and find all the registers that are visible in the graph. And then after that, I do a second pass, which then compiles all of them into a list of expressions. In particular, you then go through all the outputs and then all the registers that were reachable, and then generate basically assignment expressions. And then finally, it outputs those expressions. So it's a really nice level of abstraction, because when you're compiling this stuff, for example, concat, you can describe the types that you're going to generate based on the bit widths that are required by these. And then you compile the inner signals, and then you generate casts into this type, which might actually not generate a cast, but if necessary, it will. And then you generate a shift of one of them, and then you generate this OR of those signals together. So it's kind of a really natural level of abstraction for doing that. And I might adopt that for the Verilog stuff as well. So it might end up being quite a bit longer than this one, but it ends up being straightforward. So I might adopt the same. And I don't think I'll be able to reuse any of these compiler passes. Maybe this register gathering one. Probably not, though, because the Verilog generation is going to not flatten things, so it's going to be a bit of a different thing, but we'll see. Anyway, I'm talking a lot instead of writing code. So I think I want to work on that if syntax. So again, I've never done a procedural macro before. And I think so one of the things that's interesting about procedural macros, I need to read up a bit here, is they must be defined in a crate with a crate type of proc macro. So we actually need to have this in a separate crate. And then I guess we need to, from a user of this library, they need to actually probably import both of these, which kind of sucks, but I think that's good enough. In fact, we can call that the kaze sugar crate, which I think is appropriate. So let's go ahead and make that first. Cargo new lib. Actually, can I do this? Help. I've done lib and bin. Bin's now the default, by the way. I don't even know when that changed. Probably several versions ago. So I guess lib is what we want. I was trying to see if it would have a version for that, but it doesn't. So let's do that. Let's do cargo new dash lib kaze sugar. And then I think we probably need, I don't know if the tests need to be in a separate one then too. Hey, Mullif. I built that. Of course, I think libs come with a test by default. Yeah, they do. It works. Yeah, so let's go ahead and make this proc macro. Go with that. I could probably zoom in for you guys. Hey, Finrog. Yeah, compiled. We're done. Also, these are unhygienic, which is going to be something that we might have to worry about when we generate some of these. But yeah, it says here, like, generated functions or generated whatever have names that are unlikely to clash, which we're probably going to end up generating some intermediate variables, so we're going to have to worry about that as well. But this is fine. We'll do the same thing like this. Some ugly prefix. But yeah, I think these function-like procedural macros are the type that we need, because there's these derived ones, which is for extending or implementing functionality for a given item. I think these are called items in Rust, which is not what we want. Or is that? Yeah, because that's actually for derive on structs. So that's not what we want. Attributes is what I just described, where it's generating some code with taking this item as input, and we don't want that either. We want this to look like a function invocation, so I think we're gonna do this. So this is the kind of thing we want to do. I'm just gonna copy this code to start out with. What up? And I'm gonna build that too. Fine. Yeah, I actually do want it most of the time unhygienic. Yeah, I do need custom emotes, don't I? I'm so lazy about that stuff. Like, I'm a bad streamer in that regard. I don't do shit for you guys. Except show up half the time. Oh, no. Stupid. But so far, I think, so what I've been doing for the simulator stuff, so let me show you how this fits together. So there's Kaze, which is the actual library for building those building netlists, and then there's the sim tests, which I do as a separate crate, and that uses this build rs script to actually generate these modules into a file. So it creates this modules.rs, and then it just calls this generate function on the outputs of all these functions. And there's definitely an easier way to write this, but who cares? So then once that's done, then the lib.rs in this crate, in this test crate, has this makes this module test where it includes all that code and then uses that. So I could have just put this in this scope, but this is cleaner to me. And then it makes all these tests where it instantiates the modules and then runs them. And I really like this is kind of a nice way to integrate this, because I suspect this would be how I would use this often, is in a crate that would use one of these modules. It would contain a build.rs that would instantiate that module and then and also instantiate all of its dependencies and then generate code for that one module or whatever modules that I would choose to pull in, and then they would just be available via something like that. It might also be that I make a pattern where crates that are meant to contain like a single module would have this build.rs and then include the lib.rs, and if the lib.rs would then have the code to generate the module, then the build.rs would run that code and then output generate the simulator code, and then the lib code would have that and then include it. But maybe that doesn't work. Maybe there's a config thing to make that work. I'm not entirely sure how that would play actually, but I don't know. I need to come up with a nice way to do that. It's kind of my point. I don't know what that's going to be yet. Yeah, I'm a wiener, Finrog. I can just imagine Guro being annoyed at you laughing at that. So let's see. Oh, by the way, extra thanks to all of you watching. I know GDQ is going on, and I am not the least bit offended if you guys are watching that also in the meantime. But I appreciate you guys still watching, even though that's going on. Yeah, so I need a crate to test this, and that's why I brought that up. Is I was thinking about making a separate crate for that. Honk. Yeah, there you go, Garrett Kelly. Oh, didn't we guys catch the monkey ball run last night? That was sick. That was probably my favorite run of the year so far, and it was too late for me to catch the no source requirement Ocarina of Time run. I really want to see that too. Orb. Yeah, gotta have all the GDQ memes here too. That's great. I actually looked because for my birthday my wife got me a Untitled Goose Game coffee mug, which is awesome. It has that mess with the honk, you get the bonk logo on it, and I love it. And it's dirty right now, but otherwise I was gonna subtly drink that on stream. Oh, I didn't see the 2-player 1-controller Punch Out either. I gotta see that. Those are like top on my list of runs I need to check out later. Oh yeah, I'll show you guys this. She also got me this shirt, which I'm super happy about. That's great. Untitled Goose Socks, that's so great. Each foot is a goose. Twice the terror. Oh, thanks for finding that. Yeah, definitely be watching that later. It's great. But yeah, so I brought up the way that I put that together because I might have a separate crate for testing this sugar, but I might also just use the sim test one because it's kind of nice to verify the module by its behavior. And that also gives us more testing for the simulator. Like, it's harder to verify the module graph that's output because I've hidden away most of the internal structure of the graph, and that's definitely on purpose because I want that to be able to change, so I don't want to expose that as a public API. So I think it makes sense to test these procedural macros by or as simulator tests. I also haven't come up with a great way to simulate or to verify the Verilog output, but I might just not have tests for that. We'll see. Yeah, you definitely have to trap a kid in a phone box. Or a woman in a garage after you break her broom. What a great game, you guys. I was so charmed by that. It's excellent. Yeah, I really should have watched Awful Block. Normally I watch that stuff while I'm at work, but it's been a bit busy at work these days. Had to be too focused for that. Which is good in its own way. I'll watch it just for the 3DO game alone. What a disaster of a console. Just like the one we're making. Something to aspire to. So yeah. Point of all of that is that this needs to happen. $719.90? It could. It's up to me, so it might as well. So you make almost as good as a 3DO. Yeah, that's a selling point. But if I ever do put a price tag on it, just for the hell of it, it's going to be in $1990. It has to be. Okay, so let's go ahead and kaze sim tests and do a cargo test there. It built. Sweet. So the other nice thing about doing it here is I already have tests that use this kind of sugar, which is the mess I showed you guys before. So what I can do now is get rid of this crap. Yeah, by the way, I did think I mentioned, or I don't think I mentioned, that this actually does have the correct behavior, but I remember it made really bad code. Maybe I don't have it making that bad code in this case. Yeah, maybe not. Especially now that I generate a lot of temporaries, this might not be that bad. I think nesting stuff did. I'm not sure. But yeah, I remember it doesn't do quite the right thing. Because conceptually, this is really simple. What you do is whenever there's an if, you kind of like push a new scope onto a stack, and then every assignment that's in there, you add to a list of assignments in that scope. Or rather, there's a map from the identifier to the expression. So for every assignment, you have a set of assignments where the set is in, or the map is indexed by the identifier, like the target of the assignment. And then at the end of the if, you just rewrite these assignments again. That's where you actually emit assignments, and those assignments are the rewritten versions where you have this mux, where the two inputs, or it has this as the selector input, and then the old value as one arm, and then the new value is the other one. So it's pretty basic. But to do that without procedural macros was really a pain. And so I don't think this is the right approach. I think it's probably possible to describe that, but even just having that where you collect like a map so like let's say I assigned it to I multiple times, I really only want the last one to take an effect. So this is fairly easy to implement if you iterate over these assignments in order, because you just take the last one. So you just replace the entry for that identifier in that map. But I actually don't know of a way to do that with these macros. As far as I know, I can only basically append to lists and then match on patterns where I take like the front off of a list. So I guess if I treated one of those lists as a stack, I could rewrite it such that there would be a bunch of dead code in the generated code, and then the last one would still take. But it seems really messy, and I think procedural macros have the ability for me to be able to describe the parsing that I want to do here a lot more clearly, and that logic again a lot more clearly, and make it more robust a lot easier, because again, this had a bunch of robustness issues, even though I think the approach is about as good as it gets for this kind of thing. Yeah, lots of temporaries should be fine, but I think maybe I should clarify, because I think one of the issues that I ran into is like, if it rewrites those expressions like here, yeah, I don't remember exactly the error case, but I remember it was really messy. You'll just have to take my word for it. But I think it was a lot of these muxes ended up being nested with the same condition. I think that's what the thing that bugged me was, because that's something that the Rust optimizer couldn't deal with, I think, or I can't imagine how it would deal with that. I think that was the problem case. I'm not sure though. That was also before I rewrote the simulator generation to output a lot more temporaries, which really helped with those kind of issues, actually. I mean, if you do something like this, and then you have some assignment here that affects this stuff, like you've described two muxes as far as I'm concerned, so that I don't really care so much about, but yeah. Anyway, again, I still think a proc macro is the right approach for this. And then you have to opt in. You have to include a different crate if you want to use the sugar, which is something you usually want to do. But again, I think that's okay. We'll see. I don't know why I care so much about this design either, because I can always just change it. But yeah, at the very least, I think the procedural macro approach is going to be the easiest way to implement this robustly. Let's just go with that. Yeah, exactly, G. Superland. I like the end there. Into a sequence of out-of-order security vulnerabilities. Classic CPUs. Do you guys remember that meme format where there was that guy who looks at the dog like this, and then the dog's like looking back at him? Is that enough to describe that? Yeah, like the OU. That's what I think of when I think of that. Silly CPUs generating out-of-order security vulnerabilities. It's just so expected at this point. Yeah, I think you're right, actually, that Serde has a different one for Serde derive. I'm actually going to Google that. Yeah, in fact... Oh, actually, it's feature gated. How does that work? I'm going to find the repo. Man, I'm so glad things are open source. It does say Serde derive. Maybe they do some kind of packaging at this level or something. Yeah, so Serde has a dependency on Serde derive. Same with the dev dependencies. What was dev dependencies again? Is that for like tests? I don't remember. But then it looks like it describes this as optional. And then here we'd have the feature if you do Serde derive. Yeah, I'm still not sure how it how it gates us that way. Maybe it's just by virtue of having these two together. This means this, and this means this, which is otherwise optional. So that's probably how they package it, which is fine. I'm gonna do it as a separate crate for now, but it looks like as of that recent compiler version, they were able to just gate it behind a feature, which I think is ultimately what I would want. But I'm not gonna worry about that right now. So let's just do this. And I'm gonna call it kaze sugar because I'm lame like that. We'll do this too. And let's do something fun. Or actually, let's do something boring first. I'm also gonna close the other tabs here because there's a lot of them. Can I just do item? I can do I is, I don't know. We'll not worry about making that actually match so far. And then I think this will not work because now that's undefined here. And I think the way we do that is we actually import it now. Use kaze sugar like that. Procedural macros cannot be expanded to statements. I hope that doesn't mean what I think it means. She does say more information, so we're gonna go ahead and look at that. Mala, there are actually a lot of those, especially in the space that I work in, which is right now AI accelerators. There's quite a lot of those. And the main reason for that is usually you have a lot of parallel cores, and to make each core smaller, they make it more straightforward. Which also has a benefit that the performance of it is more predictable, which is really a nice property for accelerators, where you're compiling code to them, and the compiler needs to make very specific decisions about how to optimize the code, and it can do that if it has a better, a more robust model of how the code's actually going to execute. So you kind of you save area, which means you can fit more processors on there, and then you also make it easier to build an optimizing compiler for it at the same time. That also helps with power. Yeah, exactly. Compute cores and GPUs also take advantage of the same kind of idea. Make the cores simpler so that you can have more of them. The reason why not everyone does it is because especially if you're going to make a general purpose CPU, there's going to be so many different kinds of code that people are writing for that. Yeah, exactly. Daniel Collin says it exactly. That's a way more terse way to put it. It's terrible at running crap code. It's good at running good code. But like if the majority of x86 code, for example, is at least wildly different. A lot of people do a lot of very different things with a CPU, so it's hard to make something that works well in every case. Like at the next level of abstraction. So they try to tackle that in the hardware design, and then they leave the ISA to be the interface, which is fine, I guess. So I am actually just searching for statements in this because I don't know It's the only find here. I don't know what this actually means, that it can't be used for generating statements. Maybe the docs actually mentioned this as well. I should scroll through those too. You know, I think though it's actually where I use this is the issue when I look at this. Cannot be expanded to statements. Like this would have to be, if I did like that, for example, I think it would work. Because then it expands to an expression rather than expands to multiple statements. Oh, now it even says procedural macros cannot be expanded to expressions. That sucks. Not even if I do this. Well, then what? Where can I use these? Do I need to have an item here? I actually don't understand the issue here. Oops. Oh, maybe it can only be used out here. It can't be used in statements or expressions, but it could be used to generate like a function item, for example. And then here, I think it's that it doesn't like. Right, so now, see this or followed by a semicolon. And then it probably just didn't like I there. Okay, that's kind of crap. At least for what we wanted to do with this. Yeah, so actually, this comment does say, is there a plan to get function-like macros to work in expression or statement positions? There are hygiene concerns, but is there a plan to either resolve or dispel those concerns? Yeah, there's probably a library that does this, but I'm hoping not to rely on anything like that. Okay, but that... I'll Google that proc macro hack. I didn't really realize... Is this also the person behind this sin crate? That's pretty sick. Didn't realize. Procedural macros in expression position. Can only be invoked in item position, yeah. So that's the issue there. This crate implements an alternative type of procedural macro that can be invoked in a statement or expression position. Only works with any stable or nightly Rust version 1.31, which is fine. Implementation crate. declaration crate, then using them. It just works, I guess. Interesting. There's also a nested one for nested invocations, which is also something that I kind of want, I think. I mean, that's cool, but I was hoping not to rely on any other dependencies than this. I mean, I know you have to rely on like sin and stuff to implement these, but still, that's kind of a big turnoff for that approach. Then maybe I do need to just figure out a way to hack this with the existing macros. I think I'm going to do that, actually, at least take another stab at it, if that's going to be my other alternative. In particular, as I was describing this, I was thinking about those stacks. So actually, first I'm going to get rid of this. Actually, I think I need to do this first. No, that was fine. I hate Sublime sometimes. Why can't it do that? Okay, apparently something is open in there. Is it this? That's certainly not going to help. It's this and something else, apparently. Well, screw it. I'm just not going to delete that now, then. Oops. Try one more time, and then I'll just give up. Yeah, fine. Okay, so cargo here. Get rid of that. Yeah, I should use any other editor. Hey, Attack. I don't know if I said hi to you already. Oh, that's cool. Yeah, just Tetrasack. I actually don't know what that is, though. NAND Tetris hack computer. This was cool. Nice. I'll definitely check that out later. Awesome that you implemented that for Mister. It seems like a really good good target. Yeah, I'm impressed that Mister's actually been able to gain traction for what it is. I'm really impressed by that. I mean, obviously it's a really cool thing, so maybe I shouldn't be too surprised, but still. So I think this one wasn't breaking it. This one, I think, broke the parser here. And unfortunately, with this kind of macro, it's been a long time since I actually looked at this, so I'm not entirely sure how this worked. But it looks like what I do is I have these two macros. So this one, this impl macro, this is about actually like expanding or actually doing the parsing. So I think there's like a part up here is kind of expanding it into I think this one's sort of mostly doing the actual parsing. And once it's all parsed, then we end up with, I think it's here, or maybe it goes down to here. I need to revisit this. But the point is that one of these little blocks here has patterns for collecting all of these assignments and also recursing into other invocations to do that. So it sort of collects all the assignments. And then there's another one that expands out the code for that. I think that's sort of the idea. So, and then this other macro is just to sort of dispatch into this one, because one of the things that I do in these patterns is I add a bunch of these delimiters, and that just makes it easy to keep track of sort of the different stacks, the different things that I have here. So I think it looks like I use this left one to represent I think it's a stack of these selectors, I think I called them, or these conditionals. And then this other one is the rest of the remaining tokens. And then it looks like actually when when the rest of the tokens starts with an assignment, I actually write out the assignment directly, it looks like. What's that doing? I'm not sure what that's doing. So I think I also found this, what is it, cargo expand? And this was a Rust cargo subcommand to be able to expand this kind of code. And particularly you can expand a particular item, so you can see what it looks like when these macros expand, and that was really useful when looking at this. So I'm going to install that really quick. Yeah, exactly. It's great Rust compile times. It's not that bad though. A lot of dependencies, but seems to be okay. Oh, it's actually just downloading. It hasn't built anything. Now it's building. The syn build was pretty fast. I expected that to be slower. Oh no, is this just eating CPU? Probably. Sorry if the stream locks up, guys. That's so annoying. Yeah, I should compile that differently, but I think I can. I just haven't tried. Ugh, really? Okay, I might need to install this in a min-GW window. I'm gonna kill it now. Sorry about that, you guys. Okay, I guess we don't have that to work on this right now. I'll set that up some other time, I think. In the meantime, I think we'll just try and hack this, and if that becomes a bad idea, then I'll then I'll try to build that again. See if I can fix that issue. Worked on my laptop, so that's kind of annoying. But anyway. Yeah, lower priority would have been fine too. Anyways, I'll wait for the stream to stabilize a bit. So I think I'm gonna basically implement this thing from scratch. So I think if I do this and we do this, I think that works. It does, but then of course this test fails. Can I get that expanded from Rust? Yeah, from Rust C directly, I guess I could. Let's see, expand macro. Yeah, it does say that's a wrapper on Rust C. Pretty expanded, isn't it? Maybe I can just try that really quick, because it does suck to do this blind. So cargo Rust C, does that work? It does. And I can do... expanded. Didn't like that. Oh, pretty equals expanded. And you need to do this dash the unstable options. That's great that it's telling me that. Only accept on nightly. That's fine. No, that's downloading. That's kind of annoying, but okay. Oh, I had that for MSVC, but not for GNU. That's fine. This shouldn't take that long. At least it tells me how to do this, right? And then we run. And then what happens? What? Oh, do I need the file? I shouldn't, should I? Multiple files specified, so if I don't specify that, that's what I get. Sure. Maybe that comes from cargo. I should learn to use those profiles, shouldn't I? Because I never use the local docs. Oh, wait a minute. I think this is actually correct. Because I'm fairly certain that this has nothing in it. And this won't parse now because I commented all that out. But this would show us what that looks like. Right, and then that still doesn't have that? That's weird. Oh, wait a minute. I know what's happening, because this is in the build script. So actually, what I want to do is build.rs. Really? Maybe that's here that I do that. No, I don't think so. Ugh. I mean, why don't I just do risc-v directly, right? Maybe that just works. Oh yeah, that wouldn't need this then. There we go. Why errors? Probably because it doesn't have the dependency. I mean, I don't care about that. As long as it expands this, right? Which it did. I guess that's fine. I guess I could also, if I was working with it this way, I could just make a new crate that only does this. Just so I can see that output. Oh, can I do that? Oh, at least that would see what the command line is, huh? That would show me that, wouldn't it? That's what you mean. Yeah, that's what I wrote, right? And here, it added it there. But yeah, that doesn't seem to use build.rs. I mean, this is actually fine if I put this at the end. Which is fine for hacking on this. I don't care that it generates a bunch of errors. I think this is good enough, actually, because then I could just look at this. I'm happy with that. Although I'm going to take a 2-minute break and get some water. I'm feeling parched. And I'm back. Yeah, so this is good enough. In fact, actually, can I put the macro above that? Which is even more helpful for this. Should be able to. And then here's my expanded output. It's weird that this happened, but who cares? The formatting of this really doesn't matter. Yeah, and I think so you can see that it spits out these previous things here. And I think the reason I did that is because if you end up with like multiple assignments in here, the way I made sure that these don't break is by taking the previous value, always referring to the previous value when it does these. So that way you always end up with the last one. Although in cases like this, the last one is actually possibly dependent on these. But I think this still works out because the new value has this expression in it. Maybe. You can see as well, like this one that's in here gets expanded like this. Yeah, I don't think this is expanding correctly. So just thinking about how I need this to work. In fact, I am going to basically just start with this. Because that's sort of the easiest case. It's just a single assignment. That could be anything. So we could even say I is m.lit. And this could be true 1. It's the value and then the number of bits it takes up, which of course is implicit in this case. But anyway, you could do 128 and you'll get 1 in that case. So if I have this, then of course this I think will work in this case. So in fact, let's even remove the conditional parts that I have here. And I think this just... I think this is enough to make that work. Yeah, in fact it is. That's enough to get that to expand to something. In fact, I'm actually finding these comments a bit distracting as it is now, so maybe we do that. Yeah, that's fine. I'll do this too. Does that help? Sure. Weird, but okay. Okay, but essentially what I want to do is I want to gather up all these assignments. I guess this is kind of a special case too, because these were assignments that were outside of one of these ifs. So those we actually just want to pass through. And I think that that's what this pattern does actually. It basically says if you have an assignment and then maybe some other tokens, but you don't have any ifs that you're currently parsing, then we get this. So yeah, I think what I want here is actually like 3 lists, right? I want okay, I want a list of, wait, what is this? Oh yeah, that's the original if syntax here. And then that also calls one where we stuff the selectors in there. That's what's going on here. So this isn't actually that bad. So if we say we have the selector stack, we have let's say the assignments, because we're going to add one, and then we have the token stream. This is kind of what we're parsing. It's kind of brain fucky to think in this way, but I think it gets to be okay. So this is kind of the form that we would have there. And the only other thing is that we also need to pass that empty list here. That's sort of what's going on. So that should expand again. Oh, it said error. That probably means an error in the expansion then. And I don't know why that's the case. Oh, probably because these ones that recurse don't preserve that structure. That would have been an error in the expansion there. So I think that's probably it. Yeah, there we go. So what we want to do, I think I want to reorder these two. Because the simplest case is this case where we're not inside any if statements. That's what this means. So if we don't have any selectors on this little stack, then we just want to output these assignments as is. Because this, unlike the Python implementation, this does have the special case where you might have assignments that are outside of an if statement, which I think is something that I want to support. Because if you want to have a default value like this and then have ifs or whatever, I think that's fine. And also, you might want to have an assignment after this. Maybe that's not that important, but I don't know. To me, it seems like something that we should support inside this syntax. So let's see. Yeah, so that's what all these cases represent, is whenever we are not within an if statement. And then we have two things that can happen. We can either have an assignment and then some more tokens maybe, or we can have an if. Oh, hey, this right here is probably why this case broke, because these if patterns here don't actually have any rest tokens. They have these inner ones, but they don't have then the rest that comes after that. And actually, I think I might want to fix that issue really quick, because, well, let's get back to that. But I think I do want to fix that now, because that seems like an isolated issue. So yes, this still generates some code that might work, but we want to do this. And of course, that errors now. And that's because, yeah, there are no patterns that can have that in there. And I think this is the same case, actually. Actually, they're different, because this is the case. This would hit this pattern. And then this one, because it's inside one of these selectors, would hit this pattern. So instead of rest here, I think I want to call this inner. Actually, we'll do it for the top one first. Yeah, which is what I did here. So just with that, we have inner, like this. Because then we also need this. Right? So this would make it match, but then it's going to be missing that assignment. Hey, Bordog. Yeah, that's exactly it. It's just a word that I like. It's a Japanese word for wind, which I also think in some really bullshitty Asian tattoo on my arm sense, it's also because we're gonna be all nice and it's gonna be a breeze to write the hardware code. And it's just the syntax is so light. Stupid. Kaze is a hardware descriptor language, which I'm using to write the RTL code of my Xenowing project, which is my games console project on FPGA. I'm using this to write the RTL code easier. Is there a speedrunner called Kaze or Kaze or something? That's not someone I've heard of, but that's kind of surprising, as I watch a lot of speedruns. Yes, I'm gonna put my VHDL chakras, exactly. That's terrible. Okay, so we might actually... I might introduce another one of these lists for like the remaining tokens, because we need to, when we go into an if, we need to differentiate between these inner tokens and then the rest tokens. So I might put those in like a separate list here. Yeah, Xena Wind, exactly. This is definitely not gonna. Well, it is gonna help indirectly write performance code, or small designs at least. Oh, G Superlin, you should not have told me that. You should just make it say honk. Oh, that's great. That's a good one. I like GPIO bug especially. The MMIO map is fantastic. Oh, I'll have to have a think about that one. I'm going to make this the inner token stream, and then the rest one's going to be the remaining tokens. So we actually need to shift a bunch of stuff around here. In fact, I think this stuff's going to match here now. No. I think this is correct, actually. Scope token stream, and then not sure if that's the best way to describe it, but I think that's what I want to describe here. And then this still makes sense. Because then here, oh, this stuff gets so ugly. But then we have the point is this. This is the whole thing that I'm trying to do here. So it expands rest into this other one. So that way we sort of push this onto the stack by putting the selector here and then the rest here. And so then all these are going to match with these other remaining tokens. So we could call these outer. We can call this the inner token stream, and then this one the outer token stream, which maybe is a good idea. I don't prefer VHDL to Verilog. I think that was just a joke. Between the two, I would pick Verilog, but I want to have my own HDL for this stuff. If nothing else, just to integrate better with Rust and to describe some of the things that I tend to describe in an HDL more succinctly and have it catch more errors. Those are kind of the three main things there. Anyway, this whenever you have a selector here, you're going to have tokens out here. So I think like this is still what we do to match these. And this is always going to be the case for these other ones here. And then whenever they call these other implementations, they need to they need to pass these along. Which is the same thing we're doing here. Or here, rather. And then in this case, it's kind of interesting because here, I think it's actually wrong to do this. If we have an expression on the stack, we probably have some remaining tokens. And so what this should do, this should actually expand again. I think doing this, but so then here we have no expression, none of the inner stuff, and then, although actually the inner stuff at that point is the rest of these ones. And at that point, we're expanding here again. I think that's okay. And then at the end, it'll hit this case eventually. This is what it all collapsed to. So then here, this is where we need to, this is where we, again, push that stuff onto the stack. So then we have this select in the outer, and then instead of rest, I wanted to call that inner. Or no, actually rest is appropriate there. And then here, this one, instead of being called rest, I wanted this one to be called inner. And so then in here, we sort of mix these selectors, which I actually don't think is what I want to do here, but we'll see. Okay, that parsed. And it looks like it handled this too. So can we do this one? And I suspect we can. Oh, that was an error. Was it actually, was it an error here? No, it was not. So that's good. But it was an error here. So that means it handled. Let's see. It did this correctly. Where here it passed on the outer ones correctly as it went into that scope. And then as it left that scope, it was able to put outer back into the right position. And then that would have matched with this case. And then this would have matched with this case. Yeah, this macro is scary looking, but I think conceptually it's somewhat clean, although I might want to reorder these arguments to make that less confusing. I'm not sure. And this assignment thing is still empty because we're not doing anything with that, because the way we're generating this code is not correct. At least it's not the way I want to do it. But it's, yeah, more or less what I want. Oh yeah, here. This actually gets a little confusing. Because, so what this is saying is that if we are in an if, and we find another if, right? And then we have like these outer ones still. We actually almost want an outer stack as well. Or way to process that. Ah, this gets shitty. Yeah, it might be worth commenting this right now. I started that up here, but that's probably not nearly enough. Yeah, maybe it wasn't that complicated after all. I don't want to give up yet, though. It feels like something that's possible. As long as I can turn this into some kind of stack. Wait, wouldn't this be two separate invocations? Yeah, I think that's actually the solution. Let's get rid of this. And then this is the scope token stream. And then instead of... Yeah, I think I've got this. Maybe I'm totally wrong, but I don't think I am yet. So instead of trying to preserve this outer thing as a stack, because we have an implicit stack, we had an implicit stack in these implementations, right? So when we have this with like inner and then outer, then instead of passing outer to this invocation, we should expand this if, and then we should expand the outer without this selector added, right? I think that's actually what we want there. Yeah, there's part of me that misses Rostendo too. Definitely. That was such a fun time, and that's where it all began. Why didn't this work, though? Oh, no, oh, it's this, I think. Maybe not. I'm actually going to call this rest again, by the way. I've decided. Let's try and isolate the case where it breaks. Also, we don't need... Yeah, we'll keep that. Why not? So that already fails with just a single assignment. So let's fix that first. Oh, it's here. It's right at the top. That would do it. Yeah, there we go. So now that works. Does the rest work? I expect this would work, and it seems to. At least it parses, right? Like, Still doesn't do what I want, but if it parses, then we're a lot of the way down. Yeah, is that the RTL engineering project you're talking about, Mr. Liquid? Because that looks quite cool. The FPGA implementation. So for this case, we also need to support if inner, and then we have the rest after that. And again, this is the same. Where we just kind of pass on this previous selector stack. And then we do the rest in the same context as this one was invoked. There we go. So now all the cases parse, which is good. In fact, this one might even pass as it is now. Oh, what is this? Oh, something doesn't have a semicolon at the end of it. It seems. That's weird. Is it maybe that I did this? Because the invocation should have semicolons? That's probably it. Yeah, that's it. Okay, so what I want to do I don't like how this is putting together these selectors, for example. How did you do that in Rust? I don't remember. I mean, this is straightforward because you just yeah, I don't know what I'm saying. But yeah, these are the easy cases because we just pass through the assignments trivially. So that's, I think this stuff is done. This whole upper half here. But these selectors here, I think the previous selector is not what we want, because I think what I was doing was yeah, expanding the selector to be all of the ones in the current scope, so you get the scoping by putting them together this way. But I actually think I want to make a stack here. Although, do I need it to be a stack? Don't think so. Because I think you only need the one that's your current scope. Because I know why I put them together before. And that's because I was rewriting these assignments as they happen, but what I actually want to do is collect all of the assignments in another stack here. And then probably have another set of these. That kind of unwraps that stack again. And the reason why I want that to be a stack is because I want the... No, I don't want that to be a stack. I just want it to be a list of the assignments. So I want to sort of collect all the assignments in a list. And then at the end of the scope, right? So here, yeah, so I wanted to collect all of the assignments. And then at the end, I want it to, yeah, rewrite collected assignments. I can show you guys the Python implementation. Class if. So what this did is it would use that Python with syntax. So as it entered the scope, it would store the selector on this if object. So this is kind of our local scope. And then when it entered the scope, it actually took a copy of the current locals of the locals of the current stack frame before it enters. And then what it does is when it exits, it looks at the stack frame as it is now that we've exited the scope, and it finds locals that have been declared there, and it sees if it basically checks if all those locals, if any of them have differed from what they were in the other stack, which is what this is doing. Then we rewrite the current stack frame to include the rewritten version of it. And then we do this hack to make sure that CPython actually updates the types from this dictionary. So it's totally hacky, but like conceptually, this is really simple, where we store the selector, we collect all the locals that are in that scope, and then as we exit the scope, we rewrite all the ones that have changed. And if we ignore this, for example, like if we ignore this constraint where we only do the ones that have changed, for example, then this becomes even conceptually simpler, because then we'll just take we can collect all the assignments, and then we can output new versions of all the assignments after. And I think it actually makes sense. Function names with the underscores, something I've used as a convention. I'm not sure which ones you mean with the underscores. Oh yeah, here, yeah, this is Python. Yeah, sorry about that. I was showing the original Python implementation of this that we're trying to emulate. But yeah, this is exactly RAI stuff for Python. So init is the constructor of this class, and then enter and exit are the RAI parts. So then there's this with syntax in Python where you say with an object. And so in that case, you would do with if, and the constructor has the selector. And so that constructs the if object, and then as it enters the scope, this gets called, and then when it exits the scope, this gets called. That's what it is. Rust doesn't have that. We're trying to hack it with macros. So I know I tried to do it this way. In this implementation, it was sort of gathering these selectors together and then rewriting the statements that were there as the statements themselves came up. And I think that that's incorrect. You know, it might actually make sense to try and do this in place again, though. And then we just might end up with a lot of extra conditionals, which I might be okay with for the first version of this. So let's try and make that work more how I want, and then we'll worry about doing this like 2-pass thing after. It seems like a more tractable way to do this. I'm going back and forth on this a lot because this is the kind of code that's complicated to write. Filker, yeah, that unfortunately that doesn't work. Only because I want to rewrite the assignments. And there's no way to overload assignment in Rust. Otherwise, I would have tried to do that kind of pattern, because I think that would have been less magic, which is nice. So it looks like I memoized the previous value and then expanded and then made this the previous value, which I don't think is what I want to do. I think I want to do this. Just the same mux implementation. And the mux that I'm using here is a method on the signal type that is just syntactic sugar for the more long form mux where it takes 2 inputs and a selector. This makes this sort of the implicit input. And I might rewrite that so it's actually the selector dot mux or ternary or something, but we actually have to do this to make sure that these signals end up with the same module object, which is important for ownership reasons, but also error checking, because you don't want to be able to combine signals that are from different modules. That's a semantic error that if all the signals have a reference to their module, we can actually check as the graph's being constructed, which is something that most of the operators do. Oh, did the Python maintainers ditch getting rid of 2.x? I didn't realize. Oh, what a nightmare. What a nightmare. Let's see. So yeah, so I think this is actually wrong where we and these two together. If we rewrite these like this, I think we just want to go with the initial selector, because what'll happen is that this will rewrite statements that do an assignment like this first. Maybe it's because of the hygiene that I had issues with this. I hope not. But it'll rewrite it in terms of the inner mux, and then later it'll rewrite it in terms of the outer mux. That's what we want, which is the value after the inner mux is applied. Now, if we end up with several assignments within the same if, that means that this is going to happen multiple times, which means we'll get this with the same selector several times. So we'll get this like nested ifs, basically, that are the same condition. That's essentially what that will compile to, which is not what we want, but if it works, then it's fine, I guess. By the way, I'm going to remove this line, which was the thing that I think made it not work. So I think this actually works. Here's the test I have. Nope, it doesn't. I'm wrong. It's a cursed chat. It's like this where we got I is mux, I invert, I invert. I think that's actually correct though. Maybe not. Also, it did seem to do this nesting properly here, because we do get a rewritten I here where I is I.mux, not I am low. Right, and that's correct. But then why did this happen? I think it happened because, well, I'm not sure. I think this one got that. So I is I, and then the condition is invert. Like this is the same as just I. And you know, I might actually be able to make the mux implementation handle this case. And maybe that ends up being the solution that we do for this. That might not be the worst thing, actually. Because I think mux in, it's all references in the library. So I think function mux, it always just returns a new signal. So this is just again the convenience that's only used to try and make that syntax work. But we could detect if so A is self, and so if B is A, we can just return A, and then we don't have to make this mux, which is the kind of optimization I'm quite okay with, actually, if that's what makes this work nicely. Because really that's what these end up being. These end up being dummy statements here. So let's look at what this actually gave us. So we said to invert I twice, which is what we got here. That's fine. That does nothing. And then if invert, let's do some simpler cases here. If invert I is I, obviously that doesn't do anything interesting. Hey, what did I do here? I is I, and then if not low, then I is, which should be true, then I is not I. So actually this should produce the right logic, I think, but didn't seem to. Yeah, so with this, we have the two inverting ones here, which is fine. And those aren't rewritten as muxes because we have patterns for when there's no selector, when there's no current selector. Just like that. And then selector cases, and then also, by the way, this should terminate too. There's no reason to invoke the macro again while I'm at it. Okay, so these first two do this with no transformation as we expect. That's great. And then we have I is I if invert, right? And that's exactly what this means. I is I if invert. Otherwise it's I. That's the point there that we have. It's this if this, otherwise this. I might reorder those arguments to make that more clear, but for our purposes now, that's fine. And if I add another I as I here, that should be handled just fine. We should literally get, yeah, the same thing. I is I if it's inverted, otherwise it's I. I is I if it's inverted, otherwise it's I. So again, redundant, but these do the right thing. And if we do this, we should get just another dummy I is I at the end. which is actually what we want. This is correct. And so then, yeah, this is cursive, isn't it? So this is where it says, yeah, so this should be I is not I if low, otherwise I. So I is not I if low, otherwise it's I. Right? And that looks correct. And then if all of these also generate correct code for I is this, and I is this, and I is this, this looks good to me. And then we output I. So the point of this module is really confusing because it's all wrapped up in this stupid macro. But the logic here that I'm trying to implement is we have this module and it has an input I, and it also has a second input called invert. And the idea is that it's a pass through module. It's like a conditional invert. So it'll either just output I when invert is low, but if invert is high, then we want it to output not I. So to me, this looks like the right logic to do that because we can ignore not I, because that means the same thing, right? And then these are also going to be no ups, and same with this one. So then the meat of it is this. So I is not I if not low. Ah, I see the issue here. This is why we had that previous value thing, because the else case is actually not correct here. That's the issue. Because the I here should actually be the I before this scope. That's why we had previous there, isn't it? So in that case, I think what we did was this. And I think I had prev here. I think that's what it was. Is it this that I had to do? I mean, I have this in Git. So why don't I just look? I should let prev like this, actually. That's how I did it. So now, let previous as I, let previous as I. Here we say I is the previous value dot mux. Let prev is this I. I don't know if this is correct. Does it produce the right code? Yeah, it does. It's hard as fuck to follow, but it seems to do the right thing. Yeah, the other thing is I don't think it's correct to have prev like this in these same scopes. I think my plan with this was to introduce a new scope whenever this would happen. So you would have this. And then this prev would belong to this scope. But did I want prev in the outer scope? I think I did. So something like this. Does that make any sense? I is not I. I was doing this for each assignment, huh? That seems not like what I want, but I'm not sure. Oh, I didn't explain that, Phil Cry. I think maybe I said it earlier, but I don't think I explained that. Yeah, G Superland is right. My initial plan was to have that in Rust, and then I had trouble making the syntax work when I first tried it. So I went with Python, and that made it a lot easier to experiment with, and I got to a syntax that I was relatively happy with. And I also was able to kind of formalize the abstractions that I wanted. And when that worked, I was thinking about just leaving it in Python because I was kind of happy with that. But now I want it back into Rust because I'm going to have it generate Rust, and it just kind of, I don't know, I would like to have it in Rust anyway. There's not really a great reason other than it's typed and I like Rust, but... And yeah, I originally did want it in Rust, but yeah. Maybe not great reasons, but that's what's happening. I feel like we don't need another scope here because this already gives us a new scope for every previous value, which in this case is every assignment. I feel like that's not correct in this case, for example. But again, having a hard time questioning it if it works. I'm just surprised. So let's actually remove a bunch of these like extra things here so that we just have one conditional in here, so that makes it easier to understand. So in this case, we have this one assignment, right? And this one assignment, we see let previous is I, and then I is previous.mux, not I if not low. So that's the correct logic for I and this at this level. And that's inside this scope. So then what happens if we add I is I here? It seems like I don't need this previous variable the way I have it formulated now. But I think I actually do. For cases like this. Actually, we can do this. Just another one to differentiate it. Let's do this and something like this, where we nest stuff like this. Yeah, because this is where it's supposed to shine. We take the previous value here before this inner conditional. That's the important thing. And I think it just looked useless here because there was no inner conditional. But I think this is where it's really important, because here if m is low, I is not I, and then if m is high, I is I in this case. That would be the same case as this. So here we could say previous is I in this scope. And then we reassign I here. And so then previous refers to this I, not this one. Does that mean we lose this? This is so confusing. No, we don't, because that's this I. Yeah, this actually makes sense. This is the correct way to do this. And the only reason I'm adding a scope here is just because we reassign previous, and so we want this previous assignment to be scoped. So I actually think this is it. This is the correct implementation. And then the addition here is we'll do this. If EQ self B, then self. I like to do this. Actually, this is not where we want to do this because this is called self-module mux. So we want to solve it here. Yeah, that's what we want. So this generates not very pretty code, but it generates correct code. And I think most of the not pretty cases are cases that are bad. Maybe I'm wrong, but that's my gut feeling. Also, we haven't tested this with assignments to different variables as well. That might be kind of interesting, actually. So like, let's say we had I1 here and I2. And then we could do output 1 and output 2. This is going to make this output stupid, or the generated code pretty stupid here, but it does expand. And so now we have like these pre's with I2 and I1. And the important part there is, again, that both of these get rewritten with that mux thing. So we get these in different scopes, but we see, for example, here I2 is not I2 here, and I1 is not I1 here. So these get rewritten, and I think the prev contexts all line up. And so it ends up being that you get different contexts for these, but I think that's okay. And then the outer one wins. Is that a problem, actually? If I do something like this, now this won't work, because now I'm sort of inverting two outputs. So now the test code's wrong. So mux test, yeah, here. If I just do this, the test will work. Yeah, so it broke. That sucks. Did I route this correctly? I think I did. Yeah, because this should still be correct. I1 is not I1. I1 is I1. I1 is not I1. And I think this ends up breaking it, because you only want it to take this last one here. Oh boy. So let me go ahead and write, by the way, what this would actually look like without all the test crap. This is kind of what you'd have. Actually, this even. I think that still fails. Oh, that passes now. That's even worse. Because that should basically be a no-up. Yeah, this is kind of the issue, because if we could scope these, then we'd actually want previous values for all of the assignments, and that's why I was thinking to kind of have a pass that would collect all of those assignments. And then another one to do this kind of scoped expansion into the previous values, which are all these previous identifiers. And then again, there you want to have all the unique ones, ideally. Ugh. Yeah, I'm a bit stuck here. I think I'm gonna call it a day for today, because this is getting difficult. Can I remove this yet? Or do I have to restart Sublime or something? Yeah, that worked finally. Yeah, I'll have more of a think about this, and we'll revisit it. I'm a bit disappointed that the procedural macros wasn't a great solution for this, because we couldn't have this in these. We couldn't have that generating statements or expressions, so that's annoying. But yeah, maybe what Mr. Liquid pointed out with what was it called? Proc macro hack. Yeah, that's what it was. Proc macro hack might be the best way to do this. Anyway, I'm gonna call it a day for today, and thanks guys for hanging out. Hopefully we can get this to work soon. But yeah, I'll see you next time.